can come here. Therefore, we can add -3 in both sides. This will remain same. So we will get 6 here. Again by that theorem only. So you have to write this one. Okay, you write this due to this theorem, and again that theorem only. So we can multiply this thing by 1 by 2. So 1 by 2 is a positive quantity. There is no problem. We have already proved that 1 by 2 is a positive quantity. So if you multiply inequality by a positive quantity, direction remains same. So therefore, to multiply this thing by 1 by 2, so you get x is less than equal to 3. So which in the set theoretic notation we can write like this. Okay. So example number B. So determine the set x such that x square plus x is greater than 0. So we'll start with let x belongs to B. So we start with B, x belongs to B. Now B is this one. So x must satisfy this condition. So x square plus x minus 2 is greater than 0. Okay. So now you try to factorize this one. So you factorize this one, you got this. So we have two real number whose product is greater than 0. Okay. AB greater than 0. So we know that if AB is greater than 0, so if AB is greater than 0, so what we have? If AB is greater than 0, A is greater than 0, B is greater than 0, first condition. Second condition is A is less than 0 and B is less than 0. So we have in first, this 2 must be greater than 0. So we take number 1, this is greater than 0, this is greater than 0. Okay, and if you combine these two, what you'll get? X is greater than we add 1 in the both side, because if we add one real number, in direction of inequality doesn't change, so x will be greater than 1, and here x will be greater than what? -2. Okay, so x, and in the next case, if this is less than 0 and this is less than 0, okay, so what do you get? X is less than 0 or less than 1, and x is less than -2. So in case 1, we get x is greater than 1 and x is greater than -2. Okay, this 2 will be, when will be this 2 satisfied? At the both will be satisfied only if x is greater than 1. Okay, x is greater than 1. So therefore, from the first condition, we have x is greater than 1, and this 2, you see, from this 2, from the next 2, we'll get x is less than 1 and x is less than -2. So when will be this 2 will satisfy simultaneously? This will be satisfied only if x is less than -2. Okay, if you take x is less than 1, then what happens? You'll get 0, but 0 is what? Greater than -2, but x must be less than, and is there, right? And means one, both must be true at the time. So this both statement is true only if x is less than -2. Okay, so therefore -2. So we have B is equal to this union this. Okay, similarly, you should go for the rest of the examples. So I will just show you this one by one. So this is one example, you can just see. Okay, after that, here is an example, very nice one. This example is very important also. So try to observe this and try to understand this. If you don't understand, you can ask me. Okay, you have to try to logic out all the statements yourself. Okay, so you see, A is greater than 0, the first one. So you have to prove that A square is greater A square sorry A is less than B, then A square is less than B, and square root of A is less than equal to B. So these three conditions are equivalent. Okay, this is what we have to prove. Here A and B both are greater than equal to 0. Okay, so we consider okay, let's go through this first one quickly. So let's we consider that both are greater than 0. Okay, because if it is equal to 0, what will happen? You just go through. Okay, if it is greater than 0 or equal to if A is greater than 0 or equal to 0, then what will happen? You just go through yourself. Okay, it will be an obvious thing. Okay, it follows that A is less than 0, sorry, A is less than B, then A plus B will be greater than 0. Yes or no? A plus B will be greater than 0. Why is this? Because A is greater than 0, B is greater than 0. So you adding these two, you'll get this will be greater than 0 by the first property. Okay. Now B square minus A square. What is B square minus A square? This will be B minus A into A plus B. Because A is less than B, A minus B is greater than 0 and A plus B is greater than 0 by property 1. So you combine this one and this one, okay, from this two, right? This implies what? This will imply this B minus A is what? Greater than 0, means this is positive. So this is positive and this is positive. Now again by order property number 2, so what you will get? This product is positive, means this thing is greater than 0. If this is greater than 0, by the definition of less than B square will be greater than A square. Okay, means A square is less than B square. So this is from the C. From C, this thing is greater than 0. So as A minus B, B minus B is A is greater than 0, therefore this is greater than 0. So we get this is greater than 0. Hence we have, so this is greater than 0. So we have this result. Okay. Now you apply this thing again here. Okay. Now we have proved that if this implies this. Okay. Now if this is 2 are greater than 0, then square root of A is greater than 0 and square root of B is greater than 0. Okay. So why is this? You try to think it out. Why, if A is greater than 0, square root of A is greater than 0. Okay. So now again, since A is what, root A whole square and B is root B whole square, so therefore by apply this one again, so you will get the results. Okay. So try to write down all the details yourself. Okay, if you don't find, if you can't write that, you can ask me and we can I will discuss with you. Okay, or else if I explain everything to you, that is this will be a useless course. So I don't want to do that. Okay, so that's why I'm just giving you the notes so that you can just note down these things and uh, try to solve yourself. Okay, this part is very important. Okay, why the arithmetic mean? Arithmetic means what? Up to real number is this one. Okay, this is the geometric mean. So you have to prove that geometric mean of two positive real number is always less than equal to the arithmetic mean. So this proof. Okay, this proof is very nice actually. Okay, and it is very uh, wonderful to study. So try to go through this. Okay, go through this. This is very nice actually. Okay, this is whole square of a positive number, so it must be greater than 0. So therefore you have this one. Okay, from here only you got this. Okay, that's not a big deal. Again, you can supply the logic of every steps involved in this proof. Okay, so that is what I want you to do. You have to prove. You have to provide all the steps. Okay, and here is Bernoulli's inequality. This thing, this is done by mathematical induction. So it's not a very complex thing. Okay, so this finishes our part of order properties of real numbers. So I will give you some exercises other than this also. You go through these exercises, okay, and you try to submit at least this two, okay, 10 and 11, okay, 10, 11, and 12. This three is the assignment for your order properties of real number to be submitted in the Google Classroom. Okay, in the next class we'll do the next topic. Okay, thank you.